I've talked previously about the... Where's my pen? Okay, there you are. About that, whenever I have two routers using OSPF between them, they will have LSA to be sent forward and backward between both of them. Now, to know that what's really happening behind the scenes when I enable an OSPF routing protocol on two routers. Okay, so the first thing is that the status of OSPF when it's not enabled in a router, when you have a new router that have never been configured before for OSPF. So the status of the OSPF on the router is down. Yes, OSPF is something programmed or built in the software and the abilities of this router, but it's never been configured before, so it's down. What will happen after I configure an OSPF on this router and maybe at the same time or later on this router are the upcoming steps. The first thing, when I configure OSPF on R1, router 1, and I give it the router ID is the highest IP address configured for the interfaces of the router, or it's an IP address that you configure it manually by yourself. In case you haven't configured it, then it will be chosen automatically of the highest the highest IP address installed or configured inside the router. So maybe I've configured it manually to avoid any duplication and confusion, that I've configured triple ones and triple from quadri ones and quad twos, 4 ones and 4 twos on these two routers, and I've started to configure OSPF on R1. The first thing that R1 will do is that it will send a hello message to the other router saying that, first thing, hello, my name is 1.1.1.1 and I'm using OSPF. What about you? Just in case R2 was also configured for router ID or automatically assigned has a router ID and was configured for OSPF also, must be configured for OSPF to reply, then it will reply with hello, thank you, I have seen your message, my name is 2.2.2.2 and I'm also using OSPF. So this will takes us from the down state to the initiation state, or it's called the initiate or INIT also, if you'd like to call it so. Okay, INIT, initiate. This is what will happens. Okay, so this is initiate, this is the reply to it. It will be called then after the initiate two-way. Once both of them receives the hello message with the router ID of the other neighbor and the confirmation that yes, I'm using OSPF, they will be in the state of two-way. After the initiate, two-way will be there. Okay, so initiate is when both of them did send, but both of them must wait for the other part or the remote side to record the information that I have sent to it, to record them in its database. Just to stop the lecture in one thing, if you remember LSAs and all its complicated types, it's stored inside something called link state database, LSDB. LSDB is a database that it's built inside every router that uses OSPF in the network, and LSDB are typical between all the routers because OSPF is the only routing protocol that requires from all its neighbors to all of them to inform it about all their information, router IDs, database, LSAs, installed routers, installed networks or prefixes, and neighbors. And also it will inform all of them about itself. Just like you see in the same message that was sent, the hello and router ID, the reply was the same, also with a hello and a router ID. So both of them now knows the same information about each other. So their databases are identical. If you show a database in the first one and the other one, you will say it's that identical, no difference between them. Okay, so this is for the LSDB, leave it for now. After the two-way state, it's either we move on forward for further relationship, which is so far I believe it's either to be an full adjacency, or it's called a neighbor establish. This is called a neighbor establish, not a full adjacency, because both of them got to know each other, but no really detailed and specific information, networking information are known between them. Okay, you will see in the upcoming slide when we will have neighbor or when we will have the full adjacency relationship. Okay, so after the two-way, they will start to further discuss information between them. X start happens when a DD or a database description message is sent from the first router to the other. A database description, it's describing to the other router the content of its database and waiting from the other router to do the same with it, behave as the same way, and reply to me with the same information you have, because I have told you everything about me. I haven't hidden anything from you, so I will expect from you to do the same with me. So once the other router receives the database description, it must record it inside its database, its own database, and we are stuck in the X start right now. Once the other router do reply to me, to R1, the required database description of its own database, and I do record them inside my database, which causing us again to have an identical database between both of these routers, then we will become in what's called the exchange state. So X start, when I start to be a good neighbor and want to share everything with you, and exchange is when you show me the same or behave with me the same. Change, what is this N doing in here? So there is an N here. Exchange. Okay, so this is the exchange where database description is using, and that's it. No more database description is needed because we are done. After the exchange, I will start to send updates with several LSAs, multiple LSAs, everything about it. Some types of LSAs are called network LSAs, others are called routing LSAs. A third type code of LSAs is the summary LSA, some external LSAs, some IPv6 LSAs. I will start to give the other router specific detailed information about every networking information or technology that is related to OSPF inside me to the other router in the state of loading. I'm expecting from it to reply with me also at the same state of loading. So you can see the arrow has two heads in both of directions, so they will keep both of them exchanging information. This is maybe this is the state where most of the time happens, where it takes most of the duration of the neighbor or the adjacency relationship to occur. After the loading is completed for the third time, the database of both of them are now again identical, because whatever shared of LSAs, LSUs between from the first router to the second must be also shared from the second router back to the first one. And this is also what gets us to the same target, which are the LSDBs are again for the third time identical. And this is something mandatory and cannot be accepted in the OSPF process or between the OSPF routers. After we finish the loading state, which is exchanging the information, we are then full, which is what's called the full adjacency between two OSPF routers. Okay, so these are all the state of the neighbor adjacency between the formation of adjacency between two OSPF routers. It might stops at the two-way or completes at the full. We will just talk about this in a few minutes in the upcoming slides. Okay, so I have all of this process, the entire process is clear to you. Just to jump to the other slide, and this will be, leave my pen, jump to the other slide, the last slide of OSPF. Of course you get boards along with it. Okay, the last slide to be is that if two neighboring routers were point-to-point router, what do I mean by point-to-point is that this router is connected with a direct link to the other router. This is a cable, please extend it to the other router connected. And that's it. This case is called point-to-point connection. This is the first thing. The other thing is that in point-to-point connection, the full adjacency happens. You've just seen the full. Okay, this is what happens in the point-to-point states, and there is no problems and everything is cool and good. Just if there was a switch connected between these two routers, what do switches behave out of your control? The catastrophe of broadcast messages. If one of these OSPF routers sent an OSPF message here or any update message that uses the broadcast, it will be sent to both of these routers, replying the same thing that will be sent to the same router, again replying to both of them, which will be for the third time replied, and we will keep on this progress forever. And this is what I have described before as the broadcast storm or problem. Okay, so broadcast will happen, then we must have some type of elections. This is kind of weird because the last time we had broadcast between three switches, we used election also under the process of spanning tree protocol. And in OSPF, when there is a switch and broadcast will happen, we will also have elections, but of course not for spanning tree, for something called electing the designated router. This is only one chosen router to speak and to update all the neighbors, while the other neighbors only listens and they do not update each other. They only update VDR. What I mean is that imagine you have this type of topology. Election will take this one as the DR for some factors that I will talk about in a few minutes coming. Okay, when this router is chosen as the DR, whatever new update happens to R2, it will not inform the entire topology. If it was 2, 3, up to 100 router, it will only inform the DR that, hey, I have news happened to me today. Would you be kind enough to inform the others? Then it will see that it's coming from R2, then I will inform myself, record it in my database, and who's left? Only R3. After that, I will inform R3 that R2 has some news happened to it today. R3 will update its database and reply only to me that, okay, it's recorded and I am done. That's it. So this will eliminate again the storm of broadcast by electing one router to speak for the others, which is called the designated router. The designated router, in case it failed, then the election also will choose a backup designated router. The process of DR will take 40 seconds, I believe. And after the first 40 seconds finishes, another 40 seconds will start to elect the backup designated router. Okay, so let's take all this mess away. All of this election will happen. The election will take the DR. Who will be chosen as the DR? The first thing is that the router with the highest router priority, the router priority is a numerical value installed in all Cisco routers, all of them, and all other routers, any other vendor, okay, which is a numerical value that's in between the range of 0 and 255. The highest is the better. By default, inside your routers, it will be 128. Okay, so just in case you have 3 routers connected in the broadcast topology, this one has the priority of 200, this one has the priority of 100, and this one at the default of 128. This one will be the DR, and the second best one is this, will be the backup DR. What will this third one be called? It will be called a DR other. It's neither a main or a backup, it will be other, a DR other. Okay, so this is how to elect the DR, but just in case, I think this pen is really thick. Okay, just in case I have 3 new routers taken out of the box, all of them, then all of them would be at the default value of the router priority, and I haven't configured them. So how will we solve this? There is a tiebreaker called the highest router ID. If all of these router priorities were equal, then OSPF will not make any use of this number. It will compare between the router IDs of these routers and the router IDs of these routers. The router ID is the highest router IP configured inside a router. Maybe it's loopback, or maybe manually configured, or maybe automatically assigned as the highest IP address. And this one cannot be duplicated. It cannot be mentioned in 2 routers or all of the routers inside your network. This must be a unique number. The biggest one, maybe 4.4.4.4, and those are 4 ones and 4 twos. The biggest one, which is for 4s, will be elected as the DR. The second biggest router ID will be elected as the backup DR. Okay, so this is how election is happened. Router ID, as you see, is an IP address, so it's a 32-bit address, and finally the DR needs a backup DR, which is the second best of everything. So this is all the theoretical parts that to be discussed in the CCNA exam and blueprints of the CCNA 20301. In the upcoming video, we'll start with the labs, and let's see how much labs we will build, implement, and configure and troubleshoot. Okay, thank you for watching, and we will see you in the upcoming videos. Hi again. Two very important things that I have forgotten to mention, which is that I have just talked about the case where you get full adjacency between 2 routers in the point-to-point case, and I have later talked about the designated routers and this election, but I haven't talked about when 2 routers will be in the two-way state, because this is a big possibility to be awkward between 2 routers. Let's take this example, as I have these 2 routers connected to a switch, and it's connected to multiple routers in this way. Having a switch means that I have an election, ended up with choosing this one as the designated router and this other one as the backup designated router. Okay, so the relation and all of them are DR others. So the relation of full adjacency will occur between the designated router and DR number 1, the designated router backup designated B1, 2, 3, okay, and also BDR. Once this become a DR, also it will have a full adjacency between all of them. But for the two-way state, the two-way state happens only between the DR others themselves, whether they were directly connected through a physical link or connected through the switch, because the switch is a layer 2 device, so it's acting just like a connection in here in the middle. But this router number 3 and router number 4, they do see each other. They are having a neighbor adjacency between each other, but it stops at the two-way. So two-way neighbor adjacency happens between the DR others only. Okay, so this is where you will find two-way. In case you build an OSPF network and you try to discover your neighbors, you will see some of the neighbors are stuck at the two-way state. No worries, this means that these 2 routers, the one that you are using to show the neighbors, and this other router or these other routers, all of them are DRs. You'll have your full adjacency between your DR and your backup DR only. That's it. Okay, so this is the case where you will find the two-way state between two neighbors. This is the first thing to mention. The other thing to mention is that the new CCNA requires me only to talk about a single area OSPF and implement only a single area OSPF. What if it was a multiple area OSPF that you will see in the future? Maybe these two are in area 0 and this router that is connected directly to this router of area 0, this is in area 1. This router in the middle has an arm with area 0 and another in area 1, so it's using OSPF on both sides, but each one of them is on a different area. This will be called an area border, the border router, because it stands between two routers and it connects them. Okay, so this is something ABR must has one of its arms extended to area 0, because you know whatever area this is, then it must be connected to area 0. So whenever you see an ABR, then you know ABR is connected area 0 to area something. This is an ABR. This is the first term. The other one is that maybe this is the router that brings internet, and this is the router that's connected to my network. So bringing internet means that there is BGP, or there is another network or another province, state, another company connected to me, another bank or whatever brand that's connected to my network. Maybe it's using RIP, EIGRP, ISIS, maybe what static route, all of them, and is connected to my OSPF router. The router that is connected to another router of another routing protocol is called Autonomous System Border Router, an ASBR, because it's connected to OSPF on a side to another routing protocol on the other side, whether it was static, dynamic interior, dynamic exterior, whatever it is. Just because it's not OSPF, then this router is called an ASBR. Okay, so these are two things to mention besides the relationship of the DR other. That's enough for all the chatting of theoretical, and we will start in a few minutes with the first lab of OSPF. Thank you very much.